My name is Stella Fragkouli, and I'm a research associate at the Bioinformatics Lab at the Center of Research and Technology in Thessaloniki, Greece. And I am involved in development of machine learning methods, synthetic data generation algorithms, and variant calling methods.
My name is Nagat Masued. I'm a research engineer at Barcelona Supercomputing Center. My research focuses on generating synthetic data, AI, and multimodal data.
Synthetic data are rapidly transforming how we do research nowadays in life sciences, and they help us model complex biological datasets when real data are either scarce or hard to access. And so in this study, we actually took a step back and we asked a very simple but important question, like, how do we actually know if synthetic data are reliable? So what we did was that we conducted a systematic review across many domains of life sciences with the main aim to support trustworthy and responsible use of synthetic data in research and healthcare. So we are at a moment where artificial intelligence is becoming central to biomedical research, and synthetic data plays a key role in this transition because it helps us overcome privacy barriers and enable large-scale model development. So it is very important that we evaluate synthetic data because we could end up with AI systems that may look powerful but are not reliable. So evaluation is very critical because it ensures scientific rigor, it protects patients, and it builds a long-term trust in AI technologies that will increasingly impact real lives.
So this is really comes to trusting the synthetic data. If the synthetic data is used for a model for medical diagnosis, treatment prediction, or drug discovery, without proper evaluation, model can learn incorrect pattern from the synthetic data that they do not replicate real world data. And when those models are deployed, the clinical conclusion drawn from them could be unreliable. The core challenge is there's no one size fits all. So evaluation is deeply context dependent. So evaluating a synthetic image is completely different than evaluating a genome sequence or evaluating health records, health patient records. And so what fidelity means is completely different depending on the context of the data. The other thing is the use case of the data. Are we using the data to train machine learning model or to benchmark bioinformatics pipeline or to use it for privacy concern. So each goal has a different evaluation strategy, and some of them focus on the downstream performance and the other on the statistical performance.
In principle, our review acts as a mapping exercise. So we went out there, we saw what people are actually using and implementing in their studies, and we mapped this and we identified some gaps. So this can be seen as a first foundation on which we can start building good practices for evaluation of synthetic data, as well as standardized frameworks.
So to fully leverage the potential of synthetic data, future efforts should focus on defining a clear guidelines for assessing synthetic data, with a practical emphasis on establishing shared evaluation standards. This will not only enhance the comparability of different synthetic data generation technique, but also increase the confidence of using synthetic data in different research disciplines.